here we're once again looking at unit vectors. If you recall, earlier we said that a unit vector is a vector which has a magnitude of 1. And here we have a couple of examples of unit vectors. We have 1, 0. If we're to find the magnitude of this, we'll get 1. If we're to find the magnitude of this, we'll also get 1. Now these two unit vectors are our standard unit vectors, and we have actually given names to them. So this first unit vector is designated as I, and our second unit vector here is designated as j. Now we can use these two unit vectors to represent any vector in a plane. So here we have a vector v, which is equal to v1, v2 in its component form. This vector here can be written as v1 times 1, 0 and v2 times 0, 1 using our unit vectors. And we can see that this is true because if we multiply, distribute this, we get v1 times 1, which is v1, and v1 times 0 is 0. So now we end up with this, and v2 times 0 is 0, and v2 times 1 is v2. Now if we add the two vectors, v1 plus 0 is v1, and 0 plus is v2. So by putting our unit vectors here, we have not actually changed our vector. All we're doing is represented it in a different form. And we know all this is equal to I, and all this is equal to j. So rewriting our component form of our vector in terms of our unit vectors, we get v1i plus v2j. Now v1 here is known as our horizontal component, and v2 is our vertical component. And we can use our unit vectors along with our vertical and horizontal component to represent any vector in a plane. So here we're given two vectors u and v, which are written in terms of the linear combination of I and j. So u is given as 1i plus 1j, or simply I plus j, and v is given as 2i minus 3j. And we're being asked to find u plus v, u minus v, and 2u minus 3v. So u plus v would be u plus v. If we remove our parentheses, it's just I plus j plus 2i minus 3j. If we simplify this by combining the like terms, we get 3i minus 2j. U minus v, so this is u minus v. Removing our parentheses, this becomes negative 2i and a positive 3j. So it's 1 minus 2i, which is negative I, and j plus 3j, which is 4j. To find 2u minus 3v, we first multiply u by 2, so this becomes 2i plus 2j, and multiply v by negative 3, which gives us negative 6i plus 9i. Combining our like terms, we have negative 4i plus 11j. Here we're being asked to find a unit vector in the direction of the given vector. So here's our given vector v with components 5 and negative 12. We are also asked to verify that the result has a magnitude of 1. Now to find a unit vector in the given direction as our vector v, we can use this formula right here, where the unit vector u is equal to v in its component form divided by the magnitude of v. This is the same as 1 over the magnitude of v times the vector v. So using this format, let's go ahead and find the unit vector. So here we have 1 over the magnitude of v would be 5 squared plus 12 squared, and the square root of that. So this is 25 plus 144, 169, and the square root of 169 is 13. So this is 1 over 13 times 5 and negative 12. Now here this is a scalar quantity. So once we multiply this times this becomes 5 over 13 and negative 12 over 13. So here's our unit vector in the same direction as v. Now to find the magnitude of this, or u, we can find the square root of u1 squared plus u2 squared. So this is 5 over 13 squared, which is 25 over 169. Negative 12 over 13 squared is 144 over 169. So this becomes 169 over 169, which is the square root of 1, or just 1. So here we have verified that the result, which is this, has a magnitude of 1. Here we've been asked to find a vector v with the given magnitude of 3, and it should be in the same direction as our vector u with component form of negative 12 and negative 5. We know to find a vector v, it's equal to its magnitude times the component form cosine theta and sine theta. Here we're already given the magnitude of v, which is 3, so we're required to find cosine theta and sine theta. We know it's in the same direction as u, so we can use this information to find theta. We know tan theta is equal to b over a, which is the same thing as our y over x. So if we were to draw this on our rectangular coordinate system, this side would be negative 5 and this side would be 12. Using our Pythagorean theorem, we can get the hypotenuse to be 13. 12 squared plus 5 squared is 169, and the square root of that is 13. Now we can find cosine theta. Cosine theta is equal to the adjacent, which is negative 12, over the hypotenuse, which is 13. And sine theta is negative 5 over 13. Now to find the vector, we multiply the scalar 3 times both of these. So this becomes negative 36 over 13 and negative 15 over 13. Here we have a unit vector u with directional angle of theta, where theta starts on our positive x-axis and terminates on u. Our terminal point for this vector is point xy, which is on our unit circle. Since u terminates on our unit circle at point xy, the component form for u would be xy. We know from our unit circle also that the coordinates for x on our unit circle is equal to cosine of theta, and the coordinates for y would be equal to sine theta. So we can rewrite this as u is being equal to cosine theta sine theta. An alternative would be to rewrite this as a linear combination of I and j. So now we have cosine theta times I plus sine theta times j. Now if we have a second vector v, which is also in a linear combination form of ai plus bj, and v is in the same direction as u, so here we probably have uv going off in this direction, then v would be equal to the magnitude of v times the component form cosine theta sine theta. Or if we rewrite as a linear combination, this would be v times cosine theta I plus v times sine theta j. Since here we're multiplying v times j, since v is a multiple of u. We can also show that tan theta is equal to b over a. Since tan theta is equal to sine over cosine, and we know sine theta is equal to b and cosine theta is equal to a. So this becomes b over a. So here we're being asked to find the magnitude and the directional angle of the vector v. In part A, we're told that v is equal to negative 5i plus 4j. To find the magnitude of v, it would be our v1 squared plus v2 squared, and the square root of all that. So this becomes 25 plus 16, which is 41. So the magnitude is the square root of 41. To find the angle, we know tan theta is equal to b over a, so this would be 4 over negative 5. So theta then would be the tan inverse of negative 4/5. Now the tan inverse of negative 4/5 is actually 38.66 degrees. But because our angle is in our second quadrant, and we can tell because x is negative and our y is positive, we know theta is this angle. So our angle would be 180 minus 38.66 are 141.34 degrees. For V, in our second problem, we're told that V is equal to 8 times cosine of 135i plus the sine of 135j. We know from our formula that V is equal to the magnitude times this, so the magnitude of V is just 8. And theta is simply 135 degrees.